Have you ever wondered where new mathematical ideas actually come from? When a mathematician proves a theorem, when a new formula is discovered, or when a breakthrough changes science, where does that idea begin? Is it pure logic, intuition, randomness, or something deeper happening inside the brain? Today we explore mathematical creativity and the neuroscience behind mathematical discovery. Many people believe mathematics is purely logical, cold, and mechanical, a subject of step-by-step deduction. But that is only half the truth. Mathematics is deeply creative. It requires imagination, pattern recognition, curiosity, and sometimes sudden flashes of insight. Historically, great mathematical discoveries often begin with confusion, a problem that refuses to be solved, a pattern that does not fit, or a contradiction that demands explanation. And then suddenly, an idea appears, sometimes while walking, resting, or even dreaming. What is happening in the brain during those moments? Neuroscience suggests that two major brain systems are involved in creativity: the focused attention network and the default mode network. The focused attention network activates when you are deliberately solving a problem through logical deduction and structured reasoning. This is when you are consciously manipulating symbols and working through equations. However, the default mode network activates when your mind is relaxed, during daydreaming, resting, or walking. Interestingly, many breakthrough ideas occur when this relaxed network is active rather than during intense concentration. This explains why mathematicians sometimes struggle for hours with no success, yet solve the problem after taking a break. The brain continues processing information subconsciously, reorganizing patterns and searching for hidden connections. When it finds a useful structure, you experience the aha moment. Insight is not magic, it is prepared intuition. Without deep preparation and immersion in the problem, the subconscious mind has nothing to reorganize creatively. Creativity in mathematics requires both structure and flexibility. Knowledge without flexibility leads to rigidity, while freedom without structure produces confusion. Mathematical discovery lies between both. Unlike artistic creativity, where beauty may be subjective, mathematical beauty often lies in simplicity, elegance, and unexpected connections. Neuroscientific studies show that when mathematicians observe elegant proofs, brain regions associated with aesthetic pleasure activate similarly to when experiencing music or art. Mathematics can feel beautiful, and that aesthetic satisfaction motivates further discovery. Another crucial element of mathematical creativity is pattern recognition. The human brain is naturally designed to detect patterns, symmetry, and regularities. Mathematics formalizes these patterns into precise language. When mathematicians encounter new problems, the brain searches for analogies with previous structures. Discovery often begins by recognizing that two seemingly different problems share the same underlying structure. Intuition plays a powerful role in this process. Many mathematicians report feeling that something is true before they can prove it. This intuition is not irrational, it is compressed experience. After years of exposure to patterns and structures, the brain develops predictive models below conscious awareness. Intuition is rapid pattern recognition operating silently. However, intuition alone is insufficient. It must be validated by proof. Creativity generates hypotheses. Logic verifies them. Both are essential. Failure also plays a central role in discovery. Most mathematical attempts do not succeed immediately. Most proofs collapse. Neuroscience shows that learning occurs through error correction. Each failed attempt updates the brain's internal model, gradually refining understanding. Creativity requires tolerance for uncertainty. If one fears being wrong, exploration stops. If one demands instant clarity, experimentation disappears. Mathematical creativity requires patience with ambiguity. Visualization is another fascinating dimension. Some mathematicians think geometrically, imagining transformations and shapes, while others think symbolically through algebraic manipulation. Brain imaging studies suggest that different neural pathways are activated depending on thinking style. There is no single path to mathematical creativity. It is deeply personal yet disciplined. Collaboration also enhances discovery. Explaining ideas to others forces restructuring and clarification. Many breakthroughs emerge through discussion because language reveals hidden gaps and alternative interpretations. Teaching, in fact, can sharpen one's own creativity because explaining concepts reorganizes internal understanding. For mathematics students who believe they are not creative, it is important to understand that creativity in mathematics is trainable. It develops through exposure to diverse problems, reading proofs carefully, asking deeper why questions, exploring alternative methods, and allowing time for thought. Speed is not creativity. Many great discoveries required years of contemplation. In 2026, with artificial intelligence tools assisting computation, some students fear that machines may replace mathematical creativity. However, while AI can compute rapidly and search vast pattern spaces, genuine insight requires conceptual framing and interpretation. Humans define meaningful problems. Machines optimize solutions. The future belongs to those who combine computational tools with creative reasoning. New mathematical ideas rarely appear fully formed. They evolve gradually. Intuition becomes conjecture, conjecture becomes refined structure, and structure becomes theorem. Discovery is iterative refinement, not instant genius. The neuroscience of mathematical creativity teaches us that deep preparation activates focused networks, relaxation activates subconscious reorganization, insight emerges from pattern alignment, proof validates intuition, repeated failure strengthens understanding, collaboration enhances clarity, and aesthetic appreciation motivates exploration. The next time you struggle with a problem, do not assume you lack talent. Struggle is part of the creative process. Work intensely, then rest. Allow your brain to reorganize. Return with curiosity. Trust preparation, trust intuition, and verify with logic. Mathematical discovery connects imagination and discipline, structure and freedom, logic and beauty. Your brain is capable of generating new ideas if you feed it knowledge, challenge it with problems, and give it time to think. Mathematics is not merely memorization. It is structured imagination. The future of mathematics will not belong to calculators alone but to creative thinkers who combine insight with reasoning. I am Dr. Nazir Ali, and I will see you in the next episode.